Alright guys, we are going to learn today how to add and subtract when we have radicals. So the first thing we need to talk about is two vocab words, like radicals and unlike radicals. Like radicals are when the number underneath the square root symbol is the same. Okay, so we have three examples here. 2 square roots of 5 and 4 square roots of 5. Those are the same thing because they both have the square root of 5. 6 square roots of x and negative 2 square roots of x, those are the same thing as well because it's what's inside the square root symbol is the same. So these three examples are all different examples of what we call like terms, like radicals. The ones that are on the bottom are examples of things that are unlike. Because 2 here doesn't even have a square root symbol. It cannot be a like term with this square root of 15 that has a 15 under the square root symbol. The next example, we have an x under the square root and we have a 6x under the square root. Those cannot be like terms because they're not the same. They both have an x, but they don't have everything the same, so they're not like terms. The next one, we have a 2 under the square root and a 3 under the square root. Those are not the same numbers, so they cannot be combined. Okay, so let's add 2 square roots of 5 plus 4 square roots of 5 together. Notice that these are like terms because what's underneath the square root is the same. You cannot add two terms together that involve square roots unless the number under the square root is exactly the same. So what we do when we have like terms here, we just go ahead and combine the coefficients that come before the square root symbol. So here we're going to add the 2 and the 4 to give us the 6, and then we keep the square root the same. So this square root of 5, it doesn't become square root of 10. You don't do anything with it. You just keep it exactly the same. This is the exact same idea as if you have 2x plus 4x. What did we do when that happens? We just combined the coefficients and we kept the variable the same. We're doing the same exact thing here. Okay, so let's look at the next one. We have the square root of x. Those are like terms. So what do? You subtract the coefficients. 6 minus 2 gives us 4, and you keep what is underneath the radical the same. Let's do some practice. First example, are these two like terms? Yes, they are. They both are square root of y. So I combine the numbers that come in front. 4 plus 6 gives me 10, and I leave the y under the square root the same. Let's look at the next one. Square root of m minus 7 square roots of m. What is the coefficient that I could write in front of the square root of m? That would be 1. Just like in front of x, we have a 1x. So I can write in a 1. These are like terms because what's under the square root is the same. So I subtract 1 minus 7 gives me negative 6. I keep the square root of m, square root of m. Okay, next one. What can we combine here? It looks like I can combine this first term with my last term because they are the same. So I add their coefficients. 2 plus 9 gives me 11, and I keep the square root of xy the same. Now this middle term here is not a like term because it does not have an x. So I just add that one on. I cannot combine those, so this would be our answer. Okay, here I have 63, 175, and 112 underneath my square root. None of those appear to be like terms, but I don't know that yet because I haven't simplified these numbers. Okay, so what I need to do is simplify these first and then decide if you can combine them. So square root of 63, this is what we learned the other day, that's 9 times 7. 9 is my perfect square, so I'm going to circle that. My smartboard is clearly off a little bit, and so I get 3 square roots of 7. 175, that is, let's see here, 25 times 7 is going to be the biggest perfect square that is a factor of 175. So when I simplify that, the square root of 25, that gives me 5 square roots of 7. And lastly, the square root of 112. Okay, so the square root of 112, that can be written as 16 times 7. We might not have known that one off the top of our head. Had to do a little calculating there. So the 16 is my perfect square. So I bring out a 4, and I leave the square root of 7. Now, although we didn't think at the beginning, we can see that these are like terms because I have the square root of 7 in each one. So what do? Combine the coefficients. 3 plus 5 plus 4. That gives me 12 square roots of 7. Okay, the next example, square root of 75y. That's going to be 25 times 3y. 25 is my perfect square, so I have 5 square roots of 3y minus, now how do I simplify 27y? That's 9 times 3y. The 9 is my perfect square, so I bring out a 3. When I bring a 3 out, notice how I already have a 2 in the front. So those get multiplied together, right? So I have 2 times 3, which is 6 square roots of 3y. And then when I have the square root of 48y, that is 16 times 3y. The 16 is my perfect square, so that's 4 square roots of 3y. Now I have terms that all have 3y's in them. Those are all like terms, so I can combine their coefficients. 5 minus 6 is -1. -1 plus 4 is 3. 3 square roots of 3y. Remember to leave what's under the square root symbol the same. All right, I think this one is our last one. It is. Okay, so it says the map at the right shows the path traveled by a delivery person on his afternoon route. Write the total distance traveled as a simplified radical expression. So what I'm wanting to do is find out how far this person went, and these are all of their distances. So I have the square root of 28 plus 2 square roots of 7 plus 2 plus the square root of 112 plus 3. Let's simplify this. Square root of 28, that is 4 times 7. 4 is my perfect square, so 2 square roots of 7 plus 2 square roots of 7 cannot be simplified anymore because 7 is a prime number. It's just 1 and 7, so that can be simplified. The number 2 right here, obviously, can't do any simplifying there. The square root of 112, that is the one we just did, which was 16 and 7. So this is 16 times 7. The square root of 16 is 4, so I have plus 4 square roots of 7 plus 3. Now I combine the terms that I can combine. 2 square roots of 7 plus 2 square roots of 7 is 4 square roots of 7. But I'm going to add that to this 4 square roots of 7, which is going to give me 8 square roots of 7. And then I have these like terms. Now they do not have square roots of 7 with them, so they just get tacked on to the end, plus 5. You cannot do 8 square roots of 7 plus 5 and magically end up with 13 square roots of 7. This 5 does not have a square root of 7 with it, so you cannot combine it with the other. So this is the distance that the person went. All right, that is it. Later.